set this to record. Okay, so last time we left off, we were talking about quadratics. And those were second degree polynomials. We'll define a polynomial more in general. But let's now define or redefine the quadratic formula. The quadratic formula, and you remember last time we mentioned that's what we call a black box formula. That's negative b plus or minus the square root of b squared minus 4ac all over 2a, not 29. That looks bad. Let me rewrite that. All over 2a, where a, b, and c are the coefficients of a quadratic written in standard form. Ax squared plus bx plus c equals 0. Now, a few things of interest to us in that quadratic formula, just from looking at it. We can look at this thing there inside the square root, and we actually give that a special name. We call that the discriminant. Discriminant. Because it literally discriminates between the types of solutions that a quadratic equation can have. What we'll do later is when we investigate the graphs of quadratics, we'll actually see that solutions literally translates to where does it cross or touch the x-axis, or does it not even do that? So the discriminant is the b squared minus 4ac part alone. That is a quick calculation you can do to decide if the discriminant, or rather decide what the types of solutions are going to look like. So we'll call the discriminant just capital D. And we're going to have three possibilities. Either the discriminant you calculate is positive, the discriminant is exactly 0, or the discriminant is a negative number. Positive discriminant, what that means is you're going to have two real number solutions that are unique. They're not going to be the same number, repeated, or anything like that. So positive discriminant, boom, you got two real number solutions there. There's two other possibilities. If you have a discriminant that is 0, you're going to have one real number solution. Exactly one, no more, no less. And that kind of creates an interesting situation. As you'll see graphically, that is a parabola which just touches the x-axis at its highest or lowest point, but doesn't actually cross through the x-axis. Finally, whenever you have a negative discriminant less than 0, which is a good Bret Easton Ellis novel, you're going to have two complex solutions. And that actually makes perfect sense, because if the discriminant is negative, if this thing inside the square root goes negative, wait a minute, I'll have to be taking the square root of a negative number. And when I do that, I naturally involve I. And when I gets involved, well, that means that I'm not dealing with real numbers anymore. I'm dealing with complex numbers. When that occurs, when this situation here occurs, that means that the graph of the parabola never even touches, much less crosses the x-axis. Never goes anywhere near it, really. It is, if it's a smiling parabola pointing upwards, it's completely above the x-axis. Or if it's a frowning parabola pointing downwards, it's completely below the x-axis. And so that creates kind of a few interesting problems that we can see with that. But now let's look at an example. Let's look at an example, something fun for the TikTok generation. No, I don't make TikToks. And so that's all I have to say about that. I was going to try to find a fun way to incorporate TikTok, but I just can't. I'm not clever enough. Let's look at this particular example. Negative 4x squared equals negative 5x plus 9. And maybe our goal is to solve that. To solve that means we're looking for values of x that can be substituted into the equation that is going to work, that's going to solve it. Now, one thing we notice right off the bat is, well, if we're going to be using quadratic formula, we're going to want to have everything on the same exact side of the equation. Same side of the equation. So what are we going to have to do here? What do you guys think? Well, everything's not kosher. Everything's not on the same side of the equation just yet. We'll need to add this 5x over. And in the same breath, we'll need to subtract the 9 over. And we'll end up with this equation. Now everything's on the same side of the equation, everything's kosher, and that's just great. What we can label here, we can label this is our a. It's the coefficient of the x squared term, so it's negative 4. This is our b. This is our c. A, B, C, it's easy as 1, 2, 3. Now our goal is going to be to actually solve that. We'll do that in just a moment. We'll solve it in just a little bit. Let's analyze the discriminant real quick. Let's see, the discriminant, remember if we go back into the quadratic formula, it's the b squared minus 4ac. So we just got to roll up our sleeves. Let's compute that discriminant first. So it's going to be 5 squared, where I got 5 from right there. Minus 4 times a is negative 4. C is negative 9. And that's my attempt at closing a parentheses. There we go. It's a little better. So we do a little bit of the math together. We do some heavy lifting together. 5 squared is the 25. And then we notice over there, well, we've got minus 4 times negative 4 times negative 9. Oh boy, we got all kinds of negatives going on. So we're going to have 1, 2, 3 negatives. So it's like saying a triple negative. So ultimately it just becomes a negative. It's like the negative 4 times negative 4 becomes positive 16. But when you multiply again by negative 9, you're going to end up with a negative number ultimately. And now we can do that. 4 times 4 is 16. 16 times 9, we'll do a little bit of the mental math. 9 times 1 was 5. Oh, cool. It just comes out to 144. So we have to do 25 minus 144. Clearly that's going to be a negative number. And it looks like it's going to be negative 119. If we try out the mental math a little bit. So we get a discriminant that's negative. We get negative 119 as a discriminant. That's not too horribly pretty, but that's life sometimes. So if we have a negative discriminant, if we remember back, That means that ultimately inside the square root of the quadratic formula, we're going to have a negative number. That means that I gets involved, and that further means that we're going to have two complex solutions, no real number solutions. No real number solutions. But okay, that's fine with me. We still need to actually solve this thing. I'll rewrite the equation we want to solve here. That's exactly how we want to set it up. We'll recall that the quadratic formula, and that is something I would commit to memory, negative b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. The cool thing about that is we just computed the discriminant, the thing that goes strictly inside the square root. We already computed that bad boy. And so now we just need to kind of fill out the rest. Negative b, well, b is a positive 5. So negative b then is going to be, get blue, negative 5. Then it's plus or minus the square root of, but we already figured out that discriminant was negative 119. So we can write that in there. Now that's going to be where you're most likely to make a mistake, is computing that b squared minus 4ac, because there's just a lot of moving pieces going on in there. And all of that is over twice times a, which is negative 4. One thing we will do is remember, if you have a negative going on inside the square root, what can we kind of pull out of that? I, exactly. The first person pronoun, no, the constant in mathematics. So that'll become negative 5 plus or minus the square root of 119i, all over 2 times negative 4 is going to be negative 8. And then there's just a little bit of manipulation left. Let's say you want to write both solutions. You have the plus or minus going on. So that sends us down 2 paths. Yes, there are 2 paths you can go down. Plus square root of 119 times I. And remember that I is outside of the square root. All over negative 8. Or you can say negative 5 minus square root of 119 I all over negative 8. Folks, that's just not very pretty, but that's just how it is sometimes. You start with this original quadratic equation, and it doesn't look too particularly nasty, but it turns out its solutions are not very pretty, not very easy to deal with. How do you conceptualize those things? What do they look like? I can't tell you. Well, I can't at our current level, because this I is involved, square root of 119, blah. It's just not very fun to look at. The only thing we could maybe do is recognize that the whole bottom is negative. It's a negative 8. So if you wanted to go the extra mile, you could flip the signs on everything. You'd say, if I made that positive 8, basically I can multiply the top and bottom by negative 1. That would make this positive 5. That would make this actually a minus here. And then in general, you don't need to put positive numbers like that. So you could just say it's 5 minus the square root of 119i. On the other side, you can say that's this. Flip all the signs. And that cleans it up a little bit. That makes it look a little bit prettier. But at the end of the day, that's what the solution is, and it doesn't get any simpler than that. You could split up the numerator, but you don't necessarily have to. Those are two perfectly wonderful ways to write the solutions. So yeah, it's not always satisfying. It's not always the funnest thing in the world to do that. Do you guys have any questions about that? And we will be bringing up the quadratic formula again as we continue on through the semester. Your bell has rung. So, what we're going to look at next, we're going to look at quadratic applications, we call them. Quadratic applications. And my friends, we have to face a very unfortunate truth here. Anytime you see the word applications, that's going to be a fancy way of saying word problems. Word problems. I know you guys all like word problems. That's not true. Most of us hate word problems, all right? And I understand. And it's simply put, it's because it's the hardest form of a math problem, usually. Word problems, you actually have to incorporate more than just rote memorization of formulas. You actually have to figure out what's going on yourself, figure out what kind of math to apply, and then you've got to apply it properly and not make mistakes and things like that. And yeah, that makes it not fun. That makes it a bit difficult, doesn't it? And that is, unfortunately, there's no other way to say it. That's just life. Well, okay. Let's try out a couple of these. What we're ultimately going to end up with most likely is a quadratic formula to solve. Is some kind of quadratic equation that needs to be solved. And we're going to see from these word problems how a quadratic equation comes out of that. So quadratic applications, everyone's favorite moment in life. Let's start off with the first one. And I'll write it out in the text box. The product of two consecutive odd integers. Consecutive odd integers, what does that mean? Well, we'll talk about it in a moment. Two consecutive odd integers is 63. What are the integers? So you might look at that and you might say, what is it? Is it what? You're like, what is that? What does that mean? Well, when two things are consecutive, that means they happen right next to each other. They happen in order, one right after the other. If they're odd, though, that's kind of a key word here. If they're odd, that means that you can't just jump in and write that one number follows the next directly. Because if you have an odd number, the next number after it is going to be even. The next number after an even is odd. They flip off and they switch off, rather, I should say. And they kind of switch off after that. Okay, well, this is how it's then going to have to work. We have to find two numbers. That's our goal. And remember, just an integer is a number that is not fractional or in between two whole numbers. So the integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. But they also include 0 as well as all the negative forms of those integers, -1, -2, -3. So we're not thinking, oh, our solutions are going to be like 1.578. No, that's not going to happen here. Well, whenever you're dealing with a word problem, you have to think, hey, I have some unknown value or values, and I'm probably going to be setting up some kind of equation that relates the values all to each other, and I'm probably going to be solving that equation. And when you have equations, you're just naturally going to be using variables. There's no two ways about it. So here's what I'm going to do. I've got two consecutive odd integers. I got to figure out what they are. Let's call x. Let's say x is going to give it to you. Let's say that's the first of my integers.
It's a rap song from like early 2000s. They're just not getting your joke. Sorry.
Oh yeah, that's a that is a rap song from more ancient times. Yes, that was popular a few years ago. I apologize for that joke. It's very stupid, but most of my humor is, so that's life. Um, so we'll call x the first odd integer that we need to find. Now we could call the next one y. We're tempted to just call it y because we have a second number. It's not the same as the first number. But here's the thing. Notice they're consecutive odd integers, meaning there's a relationship that exists between them. If we try to use a y in there, we're introducing a second variable, and that means that solving it is not going to be as easy as you'd think, not without more information. So instead, we're going to actually appeal to the relationship that exists between these two numbers. If x is the first odd integer, the next integer is a consecutive odd integer, meaning while it doesn't take place right after it, it's the next odd number that takes place after it. So if x was the first odd integer, let's say it's 11, the next one can't be 12 because it's got to be odd, so we got to go to 13. If x was 17, we'd have to go to 19. So the next number has to be 2 greater than the first one. And so we're going to call that the second odd integer. Then we're just going to appeal to what it straight up tells us. The product, so when you see the word product, what do you guys think? What major mathematical operation is in your mind? Multiplication? Multiply? Yeah, I think that's what I heard. So the product of them. So in other words, the product of the first number we're calling x. Now, the second number is x plus 2, and we need to put it in parentheses because we need to remember parentheses is our way of saying the entire first number gets multiplied to the entire second number. And that needs to come out to 63. Okay, well, now we have to actually solve that. Now, when you look at this here, you look at this, this is just begging, it's just screaming for you to distribute it. Um, hopefully your mathematical intuition kind of points you to that. And so, ipso facto, we're going to get x squared plus 2x equals 63. Now, there's a number of ways that we can then solve it going forward. Let's see what I can do here. I have to give myself some more space. We'll move it all. Whoa, not that. There we go. We'll move it up here. So there's a number of ways we can solve this. In fact, there's two principal ways. We can move this 63 over to the left-hand side, and then we could either factor it or we could use quadratic formula. The other way, though, the way it's written, we can actually use completing the square. And you really have carte blanche here. You can use whichever method you're more comfortable with. It does not matter at the end of the day as long as you use a viable method and you get the right answer. So just for kicks, I'm going to complete the square. So if we recall our completing the square method, we need to take half this number, which is 1. We have to square that number. So we just so happen to stick with 1. Then we take this and we add it to both sides. We add it to both sides. So we need to add a 1 to both sides. And so ultimately what we're going to get on the left-hand side, x squared plus 2x plus 1 equals, so we need to, all right, I'll add 1 here, equals on the right-hand side, we're going to get Nintendo 64. And now the beautiful thing about completing the square is you'll recall the left-hand side becomes what we called a perfect square trinomial. And it factors as this number we added to both sides, it just factors like this. X plus 1 squared. Equals 64. And so remember, you're completing the square. What we then need to do is we would use square root property, take the square root of both sides, with the added understanding that it creates that plus or minus situation we talked about last time with the square root property. So on the left-hand side, we're going to get, I'll have to write it over here, just x plus 1 all by itself. On the right-hand side, what are we going to get? What's the square root of 64, folks? The square root of 64. What is a number that multiplies to itself and gives you 64? The ocho? That sounds about right. Plus or minus 8. So now we just need to go subtract the 1 from both sides. X equals -1 plus or minus 8. That's kind of why completing the square is really nice, is really worked out in this situation. There are two paths we can go down here. We can do -1 plus 8, -1 minus 8, and that's going to give us 7 of, not 9, but -9. And now we reach a point where we have to interpret just what the heck's going on here. Now you probably, all the way back at the beginning of the problem, you probably could have said, oh, well, if consecutive odd integers means that one follows the other, but they both have to be odd. So it could be 7 and 9, 9 and 11, 11 and 13. You probably just said, oh, well, 7 times 9 is 63. So you probably solved it at the beginning, right? Maybe some of you saw that immediately, but you only got half the answer. Because here's what's going on. There's two solutions for x. There's +7, but also -9. That's only a solution for x. Remember, the two numbers we're looking for is this x, but also this x plus 2. So here's what happens. We come up all the way over here, and we say, okay, x can be 7. That corresponds to this first solution we found. But the other answer is not -9. The other answer would be 2 more than 7, which is x plus 2, or 9. That deals with that first one. But if we also wanted to deal with this -9 here, sorry, something popped up on my screen, go away. If we want to deal with that -9, then the other possible solution is -9, and that means the second number is -7 because we add 2 to it. So there are two solutions, but it's not working out exactly the way you think. Here's the first pair of possible solutions, +7 and +9. And here's the second pair of possible solutions. Either one of those is equally valid. In both cases, you have integers. 7 and 9 are integers, but -9 and -7 are integers. So if you thought you just mental math it and only did the 7 and 9, you only got one pair of the solutions. You forgot this one. And that's why setting it up like this ended up having some real value to us. And so those would be our answers. Which one is more valid than the other? Neither. I can't say one's better than the other. They both have equal share, equal claim to being the solution. So that one's fun. I bet you guys are just having a barrel of laughs over there in the cybersphere. And so that's going to be our answer here. We're done with that one. Drop a line. Of course, you're always free to interact with me using the text box and it should pop up anytime you use the chat box here. It should try flag me down, get my attention, so I don't just ignore y'all. I do like to, what I like to do is I think it's a popular phrase right now, is social and emotional learning. There's a lot of different teachers who approach social and emotional learning in their own way. I like to incorporate humor. I like to use a little bit of humor in my lecture. You might have noticed. The only problem is that I'm not funny. I'm very not funny. I used to, when I was younger, when I was your age, when I was in high school, I was always pretty funny. People were always laughing at my jokes. They said, Josh, you should go on. You should do something in the realm of humor. And flash forward 10 plus ish years later, and it turns out they were dead wrong. They were dead wrong. I'm not funny. So we ended off class last time with a joke, and I have to apologize for that joke, not because there's anything crass or uncouth about that joke, but because it just wasn't funny. At the end of the day, that joke wasn't funny. I went for anti-humor. It didn't work. So I apologize for that. So I'm just not funny. So I'm going to be disappointing you guys all semester with my jokes. I might attempt at the end of class today another joke. I apologize in advance for it because it's not going to be funny. All right, so that's just fun, isn't it? Okay, so I have a couple other example problems. Remember, this section 1.5 is called quadratic applications. The best way to think about it is you're put into the wild without anything but your wits about you to solve these. I can't show you every type of quadratic application problem because it doesn't work like that. If you use a certain educational model called Bloom's taxonomy, we have to get you to the point where not only are you riding the bike, but I can kind of push you and let you do it yourself. That's ultimately where we're getting. We're getting to a higher level of critical thinking. Bloom's taxonomy is very popular with educators. It's also like 70 years old. So let's see. We've got two others. Which one do I want to do? Let's do this one. Okay, so I'll write out this next problem here. The area of a rectangular field is 30 square feet. And you can write that's feet squared if you want to think about it like that. Its length is 4 feet longer than twice its width. Find the length and the width. Figure out what they are. Okay, well, that's interesting. How many of you want to see, and this is a complete side note, but we'll do it. How many of you want to see a cool little math thing? How many of you want to see a cool little math thing? I don't know what else to call it, but a thing. Well, this is my class, so I'm just going to assume everyone said yes, but if not, you're going to be subjected to it. It is pretty cool. So let's talk about feet and yards real quick. And you guys might know that 1 yard is equal to 3 feet, right? A yard is 3 feet. Think a yard is the measurement used in football. And so 1 yard is 3 feet. Well, what you're not seeing maybe is that that is a one-dimensional measurement, meaning we're thinking of it just along a single straight line. But here's the thing, whenever you go into two-dimensional measurements like square feet, square yards, things like that, whenever you get into that, you're tempted to say that 1 square yard is also equal to 3 square feet. And it turns out that's actually wrong. Because let's think about it. So let's say we had, it's going to be easier to just draw it. Here we go. Let's say we had a square. And yes, that's the best square you're going to get out of me, freehand. Let's say we had a square that was 1 yard by 1 yard. Well, if you were to stick to your guns and say that 1 yard is equal to 3 feet, that means you have to say that since both measurements were 1 yard, you have to say that this is 3 feet. You have to then say that this is 3 feet as well. Same exact square, each 1 yard here, 1 yard here. But what would the area of that square be in square feet? Well, what's 3 times 3? Everyone say it out loud. 3 times 3 is 9. 9. So while 1 yard is equal to 3 feet, we actually have a slightly different problem when we go to 2-dimension. 1 square yard is equal to 9 square feet. And that's something that always confused me when I was about your age, because I remember doing these measurements and I tried to figure things out and things weren't adding up. And it's because this is how you deal with it in 2 dimensions. If you're doing it in 3 dimensions, a cube, think about 1 cubic or 1 cubic yard. That would be a cube that's 1 yard by 1 yard by 1 yard. But each of those is 3 feet by 3 feet by 3 feet. 3 times 3 times 3 is 27 cubic feet. So if you go into 3 dimensions, it goes even further than that. Now, maybe you've seen that before, maybe you haven't, but that just kind of popped into my head as something that's interesting. So sometimes I might go down an interesting path like that. Hopefully you found it interesting. Go away. There we go. But back to the problem at hand. So the area of a rectangular field. Well, guess what, ladies and gentlemen? We don't like to just walk into these kinds of problems. We're thinking about a rectangular field. Why would you not just draw a picture? Yeah, and that's exactly what I'm going to do. Draw yourself a picture. Think about it as a rectangle. Now, you don't know the exact measurements yet, so you don't know if this is really going to be much longer than this one, like I've written there. But that's okay. Its length is 4 feet longer than twice its width. So here's the thing. We need to incorporate a variable here. We need to incorporate a variable. I'm going to use the variable w for width, and I'm going to put it right there on the rectangle. Now, this seems to me, this top side here looks like it should be the length, so that forces this one to be the width. I'm going to call it w. Now, in your mind, you might be saying, Josh, how come you didn't pick L for length and make that the first variable? Because length is the first thing that shows up here. Well, if you think about it, the length is written, or it's told to you, as a function of the width. So we need to, it's almost like a y and x situation. We need width actually to be the initial variable we use. Then we can write the length up here as a function of the width. Its length is 4 feet longer than twice its width, so we got to double the width. And then it's 4 feet even longer than that. And then we're told that the area of the rectangular field is 30 square feet. Well, to find area, we would need to multiply length times width. And because we know that there's a formula for the length in terms of the width, that keeps everything in one variable. Our only variable is going to be W. That's the only variable we're going to have to deal with. There's no L's and W's going on because that would just make things a little bit more complicated. So at this stage of the juncture, we are thinking in terms of just one variable. And now let me just move this up, give myself a little extra room. So length times width, or I'll just say the width times the length, just so it kind of looks pretty. And again, I have to, just like we did in the last problem, I need to multiply by the entire 2w plus 4 expression, which means I am going to have to distribute. And it just tells us straight up that's supposed to equal 30. We can leave the units off when we're doing the actual math, when we're dealing with the numbers. We don't need the units there. And bada bing, bada boom, I'm going to distribute the w. That's going to become 2w squared plus 4w equals 30. Once again, you could complete the square. Remember, technically to complete the square, we need to divide both sides by this 2 here. So maybe we don't complete the square in this particular case, because let's expose ourselves to a different way of solving. Let us instead put everything on the same side of the equation. 2w squared plus 4w minus 30 is now equal to 0. And now there's a couple ways that we can go about solving this one. Now we kind of talked about factoring. I kind of asked you guys if you were comfortable with factoring. We could always use the quadratic formula here. And so, you know what? I'm literally going to toss a coin. We're going to decide. Toss a coin. Google, flip a coin for me, because nobody flips real coins anymore. And it's going to be tails. So let's solve it with quadratic formula. Whatever. Doesn't matter. And so the next one we'll try to solve with factoring if possible, may not be possible. Also, I don't even know that factoring will work, but I know that the quadratic formula will always work as long as I keep in mind that I might have a negative discriminant and have to deal with I. So the quadratic formula always works. That's why it's so lovely. So here's A, here's B, and here's C, and it's got to be negative 30. We'll write out our lovely quadratic formula here, and maybe we'll get one that's a little prettier than the last time. We don't have to deal with the square root of 119 or whatever that nasty business was. So let's see, let's just plug them all in. Negative 4 plus or minus the square root of 4 squared, one of my favorite games as a kid, minus 4 times A is 2, C is negative 30. All that is going to be over twice A. Well, golly gee, that is a lot, especially when you have it all on the screen there. We have limited screen space. Maybe we can mental math some of this. I'll use a different color. Let's try getting that discriminant down. I think that's going to help us. So we're going to do this kind of piecemeal. 4 squared is 16, minus 4 times 2 is 8, times negative 30, so that's going to end up being positive. And then 8 times 30 is going to be 240. And it's 16 plus 240, which will be 256. Then we have to take the square root of that. So here we run into a little bit of the problem with quadratic formula is that while it always works, the square root of 256 turns out it's going to be a nice clean square root. That's going to end up being 16. That's going to end up being 16. And that's lovely, but how did I know that? Well, it's just because I happen to have gone off at some point in my life and memorized like the first 20 squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. So I can also, backtrack, and I've seen the X number of square roots, and so I know that's going to come out to 16. Now, how do you, the intrepid young student who does not have a calculator, how do you know how to do something like that? Maybe you are comfortable with those squares. Maybe you've never seen all of them before like that. That's okay. I'll just tell you, I'll just be direct. Your exams, they will have numbers that are meant entirely to be done without the aid of a calculator. This problem that we worked together here was done with a math instructor with you. So that's just kind of the idea here is your problems on your exams are meant to be done without a calculator. Some of the homework problems, the numbers do get a little nasty and will require a calculator. That's generally okay with me, especially because the calculator is not going to help you just magically get to the answer at the end. You might just need it for a little bit of number crunching in between. But all the theory and the concepts, you still have to come in armed with that. So just take calm, I don't know what I'm trying to say. The exams aren't going to have nasty numbers on them. They're not designed to do that. So we're going to get a 16 inside that discriminant. So boy, that is, or not inside it, that's going to be what the discriminant completely reduces to, even after we take a square root of it. So we're going to end up with negative 4 plus or minus 16 all over 4. So let's clear a space. Let us prepare the way. So we can have a little more board space here. we'll go deal with this here. Let's see, negative 4 plus 16 all over 4. Then we have to do negative 4 minus 16 all over 4. Okay, let's deal with those. This one, let's see, negative 4 plus 16 is the same as 16 minus 4, which is 12. Then we divide by 4 and we get 3. Over here, negative 4 minus 16 is like negative 20. Then we divide by 4 and that gives us negative 5. So let's see the forest for the trees here. The 3 and the negative 5, those were meant to represent the width. Remember, we were solving this equation here. And this equation was going to tell us the width of this rectangle. We got two possibilities, which makes sense because it's a quadratic and we have to deal with the chance of two possibilities. But is one of these numbers nonsense in the context of this problem? What do you guys think? Is one of these numbers just silly? Yeah, it's going to be the negative 5. The negative 5 is silly in this context because what in the heck does a negative width mean? We're not going to get into some weird pseudo psychological math nonsense. No, it doesn't make sense in this context. So what we're going to say is no, the width is clearly meant to be the positive value. That's not always going to happen. Just because you get a negative number as a possible solution doesn't mean you can just automatically throw it out. It just depends on the context of your problem. The last problem we did with the consecutive odd integers, having a negative number was totally fine. There was no problem with it. So don't think, hey, I can just throw out that negative number. Don't do it. But in this case, we do have to do it. So we know the width is going to be 3 feet. Notice, though, the problem wants us to find both the length and the width. Well, no problem there. I know what the width is. So now I can figure out the length. I just need to plug the 3 we found for the width. Plug it in. 2 times 3 is 6, plus 4 is 10. So this one, the answer is 3 feet for the width, 10 feet for the length. And we had to use a quadratic to solve that. Any questions on that one? Any questions? You can use the text box. If you're with me in Zoom, you can unmute yourself and ask me a question. That is totally fine with me. But if not, we will keep on keeping on. So lots of fun. That one's in the book. Let's try one more. And we're going to try one that if you're taking physics, if you've studied physics, this one should be something interesting to you. If you plan on going to study engineering or higher level math when you get to college, this one will be especially interesting to you. This will be a fun one. So a projectile, and again, when a math person says it's going to be fun, take that with a mountain of salt because it's usually not actually going to be fun in the usual sense of the word. So that's just how it's got to be. So a projectile is launched upwards. You're launching it straight up. Maybe you have a bottle rocket at an initial velocity, which is a fancy way of saying speed, but with this direction attached to it, of 128 feet per second. So at the very moment the projectile is launched, it's going 128 feet per second. But is it going to go 128 feet per second forever until the end of time? Let's assume you're on planet Earth, good old planet Earth. No, the big bad gravity monster is going to take that thing's velocity and drain it over time. In fact, it's going to drain it so much, it's going to reach a high point, and then it's going to come right back down to Earth. And so what's happening is its height in feet, the number of feet it's above the ground, and we're going to assume it's starting at 0 feet. Its height in feet, t seconds after launch will be, we're going to use a formula for that, an equation. It's going to be h for height equals negative 16 t squared plus 128 t. In other words, if I want to know how high up the rocket has gone after 3 seconds, all I got to do is plug a 3 here. We'll put it obviously again into here. And whatever that spits out is how high the rocket has gone. Well, you'll notice, and we were kind of peering ahead, this creates a parabola that looks like this. And this is a perfect drawing of the situation. The rocket goes up, up, up. Even if it's going straight up and not going up and to the right like this still models it. It's going to reach a high point, and then gravity is going to sap it of all its upward power and take it right back down to Earth, which is why parabolas are absolutely wonderful for modeling projectile situations like this. In fact, it's almost like they're one and the same. Now, where does the 128 come from? You can tell that's the initial velocity of the rocket. If you wanted to set up your own problem and you said the rocket launches at 90 feet per second, you would just put a 90 right here. What you won't be changing if you're in feet per second is this negative 16. The negative is what's telling you that it's dragging it down because it's going to it's going to subtract away from what this thing is trying to give you. And that's exactly because this negative 16 is called the acceleration constant due to gravity. It's roughly 16 feet per second squared. We won't go into uber detail about that, but that negative 16 is something you won't change about your problem as long as you're dealing with feet and seconds as your unit. Okay, so here's a question for you. All this setup, after how much time will it reach a height of 192 feet? We'll also ask a second question, but I'll ask it in a moment. We're also going to ask how long is it going to take after you launch for it to return back to the ground? And it turns out that's actually going to be the easier question. Okay, so quick aside, I want to show you how this thing works. Let's not answer this question just yet. Let me again play with this formula a little bit and show you how it's working. If you wanted to know the height of the rocket, how high up it was, or it is, after 3 seconds, like I promised you, you would take a 3 and you'd plug it in for t here. So you'd have h equals negative 16 times 3 squared plus 128 times 3. And so then you just have to do the math magic, follow your order of operations. 3 squared happens first, so it's negative 16 times 9. And again, technically, those are calculations you could do by hand using all kind of old school multiplication. It's just kind of what you want out of life. Negative 16 times 9, we actually did that one earlier. So it'll be negative 144 plus 128 times 3. Let's see if we can mental math it. 100 times 3 is 300 plus another 28 times 3 is 84. There we go. So it's going to be 384. And this is totally just on the side here. This is just so you see how these equations are working. Then 384 minus 144, you sap the 4s, 380 minus 140. It's going to give you what, 240? So I just did that entirely so you could see what this equation is doing. You can plug in any value of time you want within a certain range, plug it right into the formula, and you can see, oh, after 3 seconds, that rocket's going to be 240 feet in the air. That's kind of cool, kind of scary if you're the rocket, some kind of anthropomorphic rocket, I guess. So that's just how that works. That doesn't answer the actual question we want here. The way we're going to answer that question is this. Well, let's think about it. If we got a value of time and we plugged it in here, that can tell us how high the rocket is. But instead, we're asked to kind of reverse engineer it here. Instead, it's saying, after how much time will it take to reach a height of 192 feet? Translation, that means that we're actually, the height is 192. That's what we know. And we're going to have to solve for t because that's what it's asking for, the amount of time it'll take. So our setup for this, we're going to plug basically 192 in for the height. The rest of it has to be written with that variable t. And that's kind of just how it goes. So now you look at that thing and you say, well, Mr. Gunther, the numbers are awful large there. And yes, I would agree with you. But like I said, you guys are maybe somewhat cool people at math and factoring and dealing with quadratics like this. Again, we come in and we're kind of teaching you this, assuming you know the basics of solving it, so you can turn around and you can do some math magic with it. Let us move this 192 over to the other side. So everything is nice and clean. So fresh, so clean. I'll give myself a little line there. Now you look at that, the numbers are massive. You could use quadratic formula. It's not going to be pretty, but here is a sneaking suspicion that I have. You can always factor out a greatest common factor if you suspect it's going to work. And it turns out maybe we could factor out a 16. Maybe we can factor out a 16 and turns out we can. We can take out a 16. So we're going to think, hey, maybe I can factor 16 out of this. But you got to factor it out of the whole thing. So that's not even an apt way to write it. And I'm even going to go one step beyond that. I'm going to factor out a negative 16 so that I don't have to deal with a negative in front of the t squared. So let's see how that's going to work. Factor out a negative 16. How do I know I can even do that? Well, I'm kind of asking for forgiveness instead of permission. What you'll see, you factor out negative 16, that's just going to become t squared. Now, since I factored out a negative number and this was positive, it's actually going to flip the sign on that. And it turns out 128 can be divided cleanly by 16. It's going to be minus 8t. The 192 can also be divided by 16. It's going to flip its sign, and it's actually going to become 12. Now, how did I know that? Am I a math magician? No, I'm not. Again, this is an example of a problem that if you're on your homework, I'm okay with you using the calculator lightly to kind of help you play around and do some of the mild calculations. Because what I'm really testing you over is, can you factor, can you solve the quadratic portion of it using the new systems and knowledge that I brought to you. So once we do that, now in terms of just solving the negative 16, we really don't care a whole lot about. It's still there, but really you can almost pretend like it's not there. Put your hand over it, either on your eye or on your screen. Watch out if you have a touch screen, because I just did that. Marcel. Are you still posting the finished Zooms on YouTube? Yes, I am. What I do is I'm recording it right now, and as soon as we're done and we stop sharing, it's going to create the video. Then I'll upload it to YouTube. YouTube takes that whole process takes about an hour, and then it'll be available. I have a playlist on YouTube. When you go to my channel, the first thing you just see is all my videos, but you can also find the Math 1314 playlist. And so, yes, you will be able to see this later. Now we just got to factor this bad boy. And so you remember you have a 1 in front of t squared. You have 12. You need two numbers that multiply to 12. But when I add those numbers, it'll add to negative 8, this middle term. And again, I am kind of walking in assuming you've seen that form of factoring before. I believe you guys told me last time you had. So that's where I'm getting from this. But if you need more clarification, shoot me a message in the Zoom chat box and I will clarify. So it turns out, it looks like those numbers are going to be negative 2, negative 6. You multiply those bad boys, you're going to get positive 12. But if you add them together, they compound their negativity and become negative 8. So that's how this factors. We took the negative 16 out of there. Your intuition hopefully leads you to take out that negative 16. And now using principle of zero products, the negative 16, again, we can just keep ignoring it. We would set t minus 2 equal to 0, but that's just, and then we'd solve it. We would get positive 2 and positive 6 here. And so, math magicians out there in the audience, we get both 2 and 6. Which one's the right answer? All right, everyone say yes if you think the right answer is 2. And only 2. Say yes if you think the right answer is 6 and only 6. Say yes if you think, Josh, they're both perfectly valid as answers here. Yes, very good. You guys are all right. I got a bunch of smarty pants out there. You're absolutely right, because again, the rocket is going to go up. After 2 seconds, it'll be at 192 feet. Then it's going to keep going up, and it's going to come back down. At some point, it's going to reach 192 feet again on the other side. That's exactly what this situation is telling us here, and that's exactly what happens. What that means is that if you think about the parabola, that's a terrible parabola, but life goes on. It's going to cross 192 feet shmia after t equals 2 seconds, and shmia again after t equals 6 seconds. So they're both the right answer. After 2 seconds and 6 seconds. That's actually really interesting to why parabolas, why they can have 2 solutions like that, why they can cross the x-axis twice. And so, yeah, that's the answer here. They're both perfectly valid. Let's ask one more question about this. Let me get rid of all this business in here. No, you go away. Same situation. Let's ask one more question about this exact same situation. That's a T. Let's say, and one more question we could ask is, how long will it, loing, that's not a word, how long will it take to return back to the ground? Well, how high up is the ground? Doing some quick math here. Oh, it's 0 feet. The ground is 0 feet because we're assuming we're starting from the ground, and we're just assuming the ground is 0 feet high. So this one actually becomes even easier than what we just did. Let's see here. In other words, after how long will it reach a height, oh my God, I cannot type today, of 0 feet? Well, what we did last time was we set the height we wanted equal to the equation itself. We're going to do that same thing. Well, gosh darn it, that actually makes something a lot easier than the last problem even. The c, the constant in a quadratic, usually it can actually create problems. If you don't have a constant, boy, that makes this simple. We can factor out negative 16 again. We can actually go one step further and factor out one level of the variable t. That's cool. We couldn't do that earlier because that constant didn't have a t attached to it, so a t couldn't come out. But here it can. And then what we're left with is just t. We've got plus 128t, but we factored out a negative 16. We argued earlier that flips the sign, makes that an 8. There's no more t with it because we factored it out. Ooh, that's not so bad. Now, when we do principle of zero products, you're tempted to just only set this part, the part in parentheses, equal to 0. But I'm going to say we're also needing to set this part because this is a factor, and especially because it has the variable attached to it. So we're going to set both factors equal to 0. Now then you're going to go over here and you're going to say on this first one, you say, Josh, why do we even do that? We could just divide both sides by negative 16, sure. and you're just going to get this big fat stinking 0. Well, yeah, you're right. Let's incorporate it. Let's include it now for the moment and see what the interpretation of that is. Over here, we would just need to add the 8 to the other side. And you're going to get 8 seconds. And I should have used burgundy, but such is life. So let's do the full interpretation. It's pretty clear the answer is going to be 8 seconds. After how long will it reach a height of 0 feet again? Will it, in other words, come crashing back down to the earth? The answer is going to be 8 seconds. It's going to be this second one. The 0 we won't quite include because it's not really the spirit of what it is. The reason we got a t equals 0 is because at 0 seconds, right before we launch the sucker, right at the moment we launch it, it is at a height of 0 feet on the ground. So that's just like saying your parabola. Oh my, I have to fix that one. Here we go. Here's your parabola. That's just asking for this point and this point. It was 0 seconds to start with. That gives you a height of 0 feet. But that's not truly in the spirit of what we're asking. It's saying how long will it take to return back to the ground. So we're assuming a little time's passed. So the answer to that then is the 8 seconds. But it's interesting to know the math works out. That t equals 0 still came out of this as it should. It's just not quite what we're looking for here. Everyone out there say, wow, Josh, that is really interesting. So much enthusiasm. I hear it in your voices. I'll tell you what, nothing gets me more excited than the enthusiasm of my students. And yes, I will be falling into a George W. Bush impersonation every once in a while. You guys should have been alive for George W. Bush. You were alive for a little bit of his time as president, so you can't pretend you don't know who that is. We're going to look, we only have 4 minutes. We're just going to barely start the last section I would like to cover today. And we're going to literally just touch it. We're going to look at section 1.6. This one's actually going to be a little bit challenging. Not that the last stuff has been a cakewalk per se. Other types of equation, and that sounds exactly like, there we go, bad grammar. Other types of equations. The only thing we're going to cover is actually a very simple math topic here. How many of you have ever heard that you can't divide by 0? Have you ever heard that you can't divide by 0? Well, you can divide 0 by something. I can do 0 divided by 4, and that equals 0, and that's totally fine. Because think about it. When you're dividing, you're asking, what does the bottom number need to be multiplied by in order for me to get the top number? Think about it. When you do 12 divided by 4, the answer to that, you're asking, what number does the 4 need to get multiplied by in order to produce 12? That's exactly what division is. And you can tell that's 3. But now there's a problem. If you divide by 0, if you take 6 and you divide by 0, you're tempted to just say, oh, that's equal to 0. But that's actually not true. The math falls completely apart, and you have to turn it upside down on its head. If I take 6 and divide it by 0, I'm asking 0, the bottom number, 0 times what is going to give me 6? What do you guys think? Is there any number that you can multiply 0 by and get 6? Ooh, that's dicey. You're asking for what it is? It's nothing. There's nothing, and it's not the number 0. No. This is what we say is undefined, and I'm not going to write that out. Undefined. Or sometimes you see DNE does not exist. There is no answer to that. You cannot divide by 0. You cannot divide by 0. You can't do it. You don't get 0 as the answer. You get nothing as the answer. You don't get any number. It doesn't make sense when you just think about the basics of division. Now, you might say, okay, well, 6 divided by 0 doesn't work. Negative 1 million divided by 0 doesn't work. What if I do 0 divided by 0? Okay, so 0, the bottom number here, 0 times what number gives me 0? Somebody out there in the classroom, shout out a number I can multiply 0 by in order to get 0?
All real numbers.
All real numbers, exactly. You can use anything you want, and that is another problem. Earlier, 6 divided by 0, there was nothing that would work. But when you do 0 divided by 0, everything works. Too many things work. We like to have just one solution if it's possible, or we'd like to narrow it down. So we're still going to say that's undefined, even 0 divided by 0. So the bottom line is you cannot divide by 0 ever. That is going to motivate why when we solve rational equations next class, why we have to throw out certain types of solutions. It's because they would have caused us to divide by 0. That's going to be a critical part of it. So you cannot divide by 0. That's a mathematical impossibility. In calculus, you touch on the idea, but you don't quite do it. You use something called a limit, and you're not exactly doing it. You're trying to go about it roundabout. It's 9 o'clock. Thank you guys so much for a wonderful day. I hope you guys are enjoying this and learning from it. You guys do have some homework due this Thursday, and then you have your exam next Thursday, September 10th. So keep that in mind. Shoot me a message or an email if you need have any questions, and make sure you get into MyLabs Plus and make sure you've submitted that photo of yourself holding your ID. Y'all have a great day. Thank y'all.